Okay, so I'm gonna go ahead and get started, going over these 4 problems. So this is exponent rule problems that are on your exam or your major quiz number 3 on Wednesday. The first problem, 3x squared over 4x to the second power. Remember that everything inside of the parentheses, the exponent gets distributed to it, and like this 3 has power of 1, this 4 has a power 1, the x has power 1. So when you distribute it, you get 3 squared, x to the 2 times 2 is 4, over 4 squared x squared. And then what can I do from there?
I mean, you can go ahead and take the squares 9 and 4.
So
9 and 16.
Yeah, 3 squared is 9, 4 squared is 16. And then what about the x's?
It becomes x to the second power on the bottom, cancels out the top.
You subtract it, yes, and then 4 minus 2 is 2, but it goes where the bigger one is, so it's on top because you have 4 on top and 2 on bottom.
Oh, I thought that
So
was on the bottom.
Leftovers are going to be on top. It goes where the bigger exponent is. Because the picture is like 4 x's on top, 2 x's on bottom, and when you cancel them out, that's 2 are left on top.
It would go to the bottom, it feels like a negative.
Oh, that's right. Okay, that's okay. Sorry, still waking up.
You're good. Okay, look at number 2. 15x to the third over 10x to the 12th. The x to the third next to the 12. 12 minus 3 is 9.
Mhm.
And where's that going to go, on top or on bottom?
Wow.
On bottom. X to the 9th on bottom because there's more of them on bottom here. And then 15 and 10, that can reduce. Both divided by 5. So 15 divided by 5 is 3. 10 divided by 5 is 2.
Mhm.
So your answer is 3 on top over 2x to the 9th on bottom. Look at number 3. Got a lot of things to do there. First thing, if you fix your negative exponents, I need to move x negative 7 down, y negative 4 up. So when you do that, you're left with 2y to the third, y to the 4th on top. On bottom, you have 8x, x to the 7th. And then from there, put your x's and your y's together. So y to the third, y to the 4th would be y to the 7th on top. X and x to the 7th, this is like x1 and x to the 7th, would be x to the 8th on bottom. And then the 2 and the 8 reduce to what? 1/4. So you can put a 1 on top. You don't have to put a 1 on top, but the 4's got to go on bottom. And that's your answer. Questions about that? Okay. Look at number 4. On number 4, I have to distribute that negative 2 to everything inside. So it becomes 2 to the negative 2, x to the positive 6, y to the negative 2, over 3 to the negative 2, x to the negative 2, y to the positive 10. From there, you want to move your negative exponents. So these 2 guys on top move down, these 2 guys on bottom move up. So when you switch everything, you get, let's see, 3 to the positive 2, x to the positive 2, x to the positive 6, over 2 to the positive 2, y to the positive 2, y to the positive 10. And then you can put together your x's and your y's. x2 and x6 on top make x8. y2 and y10 on bottom make y12. 3 squared is 9. 2 squared is 4. So that's your answer. Questions about that? Okay, so that's exponent rules. They're not gonna be any harder than that. They might be easier than that, but if you can handle that one we just did, you should be good on basically any problem that you get on your test.
All right, see you later.
Questions about that? Okay, so that's the first part of your exam. The next thing is rational exponents. Remember, if you have a fractional exponent, the number on top represents the power, the number on bottom represents the root that you're taking of it. So that we can make this problem work, go ahead and make that a +9. Doesn't really work unless you make it a +9. So for this problem, to the 3/2 power, what does that mean?
Square root of 9 to the third power.
The square root of 9, and then I'm going to raise it to the third power. Remember, you could do to the third power at the beginning, or you could do it at the end. If you wait till the end to do it, it makes it a little bit easier because they're smaller numbers. So what's the square root of 9?
That's right.
Square root of 9 is
3.
3, and then 3 to the third power is 27. So your answer here is 27. Okay, look at number 6. 32 to the 2/5 power. What does that mean?
The 5 root of 32.
The
The second
5th root
power.
of 32, and then we're going to square it at the end. So the 5th root of 32, what times itself 5 times gives me 32?
Probably 2.
Probably 2, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and then the last one, 16 times 2 is 32. So yeah, the 5th root of 32 is 2, and then 2 squared is 4. Questions about that? Okay, 7 and 8 are the ones that we've been doing as like review problems. So this is where we put it as rational exponents first, put them together, and then like using exponent rules, and then put it back as a radical. So how do I write the cube root of a squared with rational exponents? A to the 2/3 power times the 6th root of a to the 5th would be a to the 5/6 power. So then we want to do what with those exponents? How do I put them together? Yeah, first I need to add them together. This is the product rule. So this becomes a to the 2/3 plus 5/6. And I need to find the common denominator, right? I'm gonna come down here and add my fractions. 2/3 plus 5/6. I need to get a common denominator. What would the common denominator be? 6. So I want to turn them both into fractions with the 6 on bottom. 5/6 already has a 6 on bottom, so it's finished. 2/3, the way I turn it into a fraction with the 6 on bottom is by multiplying by 2 on bottom and on top. So I get 4/6 plus 5/6, which is, what's 4/6 plus 5/6?
9/6.
9/6. And then can I reduce that? Yeah, to 3/2. So this becomes a to the 3/2 power. And if I want to write that with the root, so let's switch it back over to the roots. What would that be?
Square root of a to the third power.
Square root of a to the 3rd power. Questions about that? Okay, so let's move on to the next one. Number 8, same idea. This time it's division problem, which means you're doing what to your exponents? Subtracting them. So when I rewrite it, it becomes b to the what power?
3/2.
2/3.
2/3. Sorry, I was gonna.
You're good.
It's easier. It's the other way around. No joke.
2/3 power, and then the 4th root of b would be b to the 1/4. which that becomes b to the 2/3 minus 1/4. If I want to do 2/3 minus 1/4, I need to change that into fractions that have a common denominator of what?
3
Mm-mm.
or of
12,
yeah.
yeah.
the multiple.
Uh-huh. So yeah, they both need to turn into a 12. The way I turn a 3 into a 12 is by multiplying it by 4. And so I get 8/12. The way I turn a 4 into a 12 is by multiplying it by 3. So I get a 3/12 there. And 8/12 minus 3/12 is 5/12. So this becomes b to the 5/12 power. And how can I write that with a radical? The 12th root of b to the 5th power.
Doesn't matter where we put the file, can we do the parentheses with that?
Yes. It does not matter if you write it like this or if you write it like this. Same thing. Okay. Questions about that at all? Okay, so that's basically half of your test is exponent rules and rational exponents. The other half of your test, if you turn it over, for number 9, distance and midpoint, you get a formula for that. Let's go ahead and write that down. Your distance formula that you get is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And your midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Sorry, it's kind of messy. Okay, so take a second and find the distance and midpoint between those 2 points. So remember, if you label them x1, y1, x2, y2, sometimes it's easier to plug them in a little bit. For distance formula, when you plug it in, you get the square root of -2 minus 3. Hey, heads up, I put x2 minus x1, y2 minus y1. Oh gosh. That's right, you subtract them, but it doesn't matter. It could be 1 and 2, 1 and 2. I think the one on your test says x1 minus x2, y1 minus y2. It doesn't matter which one you put first, as long as these two match up and these two match up. Does that make sense? Okay, and the reason why it doesn't matter which one you put first is because it didn't matter which one you labeled your order pair as. Okay, so -2 minus 3 squared plus 6 minus 4 squared. And then you subtract each of them. -2 minus 3 is -5 squared. 6 minus 4 is 2 squared. And then you square each of them. What is -5 squared? 25. Positive 25, remember, never negative. What is 2 squared?
4.
And 29 plus 4 is 29. So the answer is the square root of 29. You could get a decimal approximation for that, and if you did that, the decimal approximation would be the square root of 29 is 5 something, 5.385.
You want us to put the decimal down?
Just whatever it says. This didn't say, so it doesn't matter. But if it says a 3 decimal approximation, that would be what the 3 decimal approximation is. So that's distance formula. How do you find midpoint formula? Use this one and plug it in. X1 plus X2 is 3 plus -2 over 2. Y1 plus Y2 is 4 plus 6 divided by 2. 3 plus -1 is, nope, 3 plus -2 is 1 divided by 2. 4 plus 6 is 10 divided by 2. And that can reduce to 1/2 and 5. Questions about distance formula or midpoint formula? Okay, and then the last things is all the radical stuff. So if I add, subtract, nope, add or subtract, multiply, and then down here's all the divide stuff. Okay, so adding and subtracting, remember your root has to be the same, and then you add or subtract the numbers in front. On this problem number 10, are my roots the same? No, can I make them the same? By simplifying them. So take 18 and break it down. 18 breaks down into 2 times 9. 9 is 3 times 3. So 18 is like 2 times 3 times 3. You can take the 3's out. So it becomes 3 times the square root of 2. '98, same idea. I need to break down 98. 98 is 2 times 49. 49 is 7 times 7. So this becomes 2 times 7 times 7. Can take out the 7's. And you get plus 7 times the square root of 2. And then minus the square root of 2. It's just minus the square root of 2. I can't break that down anymore. But now are all of your roots the same? Yes, they're all the same. So that means that we can just add or subtract the numbers in front. So what is 3 plus 7 minus, what's the number in front of this one? 1. So 3 plus 7 minus 1?
10 or 9.
Yeah, 3 plus 7 is 10. 10 minus 1 is 9 times the square root of 2. Questions about that? Okay, look at number 11. 11 is a multiplication problem. You're just distributing. Remember, you multiply outside numbers with outside numbers, inside numbers with inside numbers. So when I distribute this square root of 3 to my other parenthesis, I get the square root of 3 times 2 square roots of 3 is 2 square roots of 9. And then I want to do square root of 3 times negative square root of 2 is negative square root of 6. And then 5 times 2 square roots of 3.
10 square root of 3.
10 square root of 3, yeah. So plus 10 square root of 3. And then 5 times negative square root of 2. It's negative 5 square roots of 2. Can I add those together, like combine like terms? No, why not? because they don't have the same root. Square root of 9, square root of 6, square root of 3, square root of 2 is all different. So I can't add them together like I did over here because these had square root of 2, square root of 2, square root of 2. Can I simplify anything?
Yeah,
Yeah, the 2 square roots of 9. What's the square root of 9?
3.
3. So that's 2 times 3, which is 6 minus the square root of 6 plus 10 square roots of 3 minus 5 square roots of 2. That's my answer. Questions about that? Okay, so 12, 13, and 14 is what we did last time. That's the rationalizing. Okay, so these are a little bit harder than the ones that, these are like the hardest of the hard, okay? It doesn't get any harder than this. So if you can handle this, you should be fine on your test. Let's think through, even though this one has an X in it, we didn't do any X's last time, it's still the same exact concept. How do I rationalize a square root problem? What do I multiply by? You remember? Remember the problem's the denominator? So I multiply by the denominator both on bottom and on top. Remember that? And I'll do it in just a second. How do I do a cube root problem? Do it 2 times. Multiply by the denominator on bottom and top 2 different times. And then this bottom one, this is one where I have more than one thing on bottom. What do I multiply by here?
The conjugate.
The conjugate. So, and is it to the top or the bottom? Always the bottom. Who cares about the top? Okay, so you take the bottom, find the conjugate. What's the conjugate of this one? Square root of 2 plus the square root of 3, and you do that on bottom and top. Okay, so that's what we're going to do for these 3 problems is multiply by essentially the denominator or the conjugate of the denominator. So for this one, square root of 5 over 7x, remember I can break that apart into a square root of 5 on top and a square root of 7x on bottom. Does that help a little bit? See what you need to multiply by now? What's the denominator that I need to multiply by? The square root of 7x. It's weird because we didn't do any x's. It doesn't matter. Whatever's in the denominator, that's what you multiply by. Okay, so on top, what's the square root of 5 times the square root of 7x?
35x.
Yeah, the square root of 35x. On bottom, if you work it out, you get the square root of 7x times the square root of 7x. What's the square root of 7x times the square root of 7x?
Square root of 49x to the second power.
Good job. Square root of 49x squared. And I can take the square root of 49x squared. That's the reason why I picked that to multiply by. What is the square root of 49x squared?
49x.
Mm-mm.
Or 7x.
7x, there you go. Because remember, I have 2 7s, I have 2 x's, I can pull the 7s out, pull the x's out, and I get 7x. And on top, it's still the square root of 35x.
Simplify those 2.
You cannot simplify those 2 because this is an inside number, that's an outside number. And that's your answer. Questions about that? Look at 13. That's a cube root problem. So first, let's break it apart into the top and the bottom. The cube root of 3 on top over the cube root of 5 on bottom. So now, what do I need to multiply by to rationalize this?
5.
The
2 times
cube root of 5.
cube root of 5.
Both on bottom and on top. So cube root of 5 on bottom and on top 1 time. And again, another time, the cube root of 5 on bottom and on top. So when I multiply it, what's the cube root of 3 times the cube root of 5 times the cube root of 5? 5 times 5 is 25. 25 times 3 is
15. Or
75. Yeah.
no, 7.
So cube root of 75. What's it going to be on bottom? The cube root of 5 times 5 times 5 is cube root of 125. And what is the cube root of 125?
5.
5. So this becomes the cube root of 75 on top over 5 on bottom. And that's your answer. Questions about that? Okay, the last one is the one where you multiply by the conjugate. So remember, the conjugate is the bottom. Just change the sign, the square root of 2 plus the square root of 3. And you do that both on bottom and on top. Okay, so a heads up, like one the common mistakes I see on this, there's 2 common mistakes I see if you get this problem wrong. Usually it's because you did square root of 2 minus the square root of 3 on bottom and on top. Why is that wrong? If it was a minus.
Conjugate.
Yeah, it's not the conjugate. You have to change the sign. It's not going to cancel out if you don't change the sign. The other thing I see commonly here is people do the square root of 2 plus the square root of 3 on bottom. On top, they do square root of 3 minus the square root of 5. It's got to be the same on bottom and on top, and use the bottom to figure it out. Okay. So go ahead and take a second and multiply. Remember, this is a problem where you're going to have to distribute everything. Go ahead and distribute out the bottom, distribute out the top. Okay, so when you distribute it out, keep working if you're not done. You should get the square root of 6 plus the square root of 9 plus the square root of 10 plus the square root of 15 on top. On bottom, you should get the square root of 4 plus the square root of 6 minus the square root of 6 minus the square root of 9. And then you check on the top, check on the bottom, see what you can simplify. On top, square root of 6, square root of 9, square root of 10, square root of 15. Can you put any of those together? Can you put any of those together on top? No. Can you simplify any of them?
Yes.
Yeah, square root of 9 is 3. So on top, you're going to get square root of 6 plus 3 minus square root of 10 minus square root of 15.
Wait, why is it minus the square root of 10?
I don't know. Plus, I was looking at the signs on the bottom. Plus, on bottom, square root of 4 is 2 plus the square root of 6 minus the square root of 6
Okay, so it's
is 0. So 2 plus 0 minus the square root of 9 is 3. So 2 plus 0 minus 3 is
-1.
-1. So a -1 on bottom. If this was any number except for -1, you would be done at this point. If this was a 2, if this was a 7, whatever, you'd be done. The fact that it's -1, how do you divide by -1?
By itself.
Like if you just did 3 divided by -1, what'd you get? -3. It just changes the signs of everything, right? So this becomes negative square root of 6 minus 3 minus the square root of 10 minus the square root of 15. And that's your answer. Questions about that? Okay, so this essentially is like your test that you're having on Wednesday. I would say a lot of the things are actually a little bit harder than what's on your test. The only thing that wasn't on this practice, in class practice we just did, that is on your test is like number 8 and 9 that's on your review. The linear inequalities. That's the only thing that we didn't go over here.
It said 8 and 9.
Yeah. So make sure if you don't do anything else, I'd encourage you to do this review. Obviously, 5 bonus points on your exam. But if nothing else, at least do 8 and 9 to make sure you know how to do it. But if you look over it, 1 through 7 is all exponent rules. 8, 9 is the inequalities. 10 and 11 is just like 5 and 6 that we just did. 12 through 15 is an easier version of 8 and 9 because it's already written in exponent the rational exponents, all you have to do is add them or subtract them. And a lot of them have a common denominator. 16 and 17 is exactly like 7 and 8 we just did. 18 through 22 is all adding, subtracting, multiplying. And then 23 through 26 is the rationalizing. And then 27, 28 is the distance formula and midpoint formula. So we have a little bit of time. Would you like to go over any of these?
Number 8.
Number 8, let's do number 8. That's a good call. So look at number 8. Number 8 is negative 5x plus 4 is less than or equal to negative 4 times x minus 1. So remember, linear inequalities are very similar to solving equations. The only difference is if you multiply or divide by a negative number, you have to turn your less than or greater than sign around the other direction, right? So for this problem, what's my first step to solve this inequality? Yeah, distribute this negative 4. So I get negative 5x plus 4 is less than or equal to negative 4 times x is negative 4x. Negative 4 times negative 1 is positive 4. From there, I need to move my x's to one side. Again, it doesn't really matter which side you move it to, but remember it's easier if you move your x's to this side, so it's easier to graph it and write interval notation. So I'm going to move negative 4x over to the the left-hand side by adding 4x to both sides. When I do, I get negative 1x plus 4 is less than or equal to, those undo each other. I just have 4 over here. How am I going to solve for x? Subtract 4 from both sides. And when you do, you get negative 1x on the left-hand side is less than or equal to 4 minus 4 is 0, which is weird, but isn't 0 just a regular number? Yeah, you can have 0 as an answer. I'm not quite done yet. How do I get x by itself? Divide by negative 1. You could also multiply by negative 1 if you wanted to. Did I multiply or divide by a negative number? Yes, you did. That's the big rule. If you multiply or divide by a negative number, remember this guy has to turn around and face the other way. So the negative ones undo each other on the left-hand side. I get x. And then 0 divided by 1. It's like weird. Is that the one you're not allowed to have? Can't remember, type in your calculator. 0 divided by negative 1 equals 0. So x is greater than or equal to 0. Graph it on a number line. So at 0, is it going to shade to the left, to the right?
Shade to the right.
Shade to the right. Is it a bracket or a parenthesis at 0? Bracket. That's your number line. What is your answer in interval notation? Bracket 0 to infinity parentheses. All three of those are your answer. What else?
Number 15.
15. I'll turn my picture over.
I think I ran into a problem like that on that homework that I did not get at all.
So y to the 1/3 over y to the 1/6. So it's already written with rational exponents. You don't have to switch over to rational exponents here. This is the quotient rule. So this means I subtract my exponents. So I get y to the 1/3 minus 1/6 power. So to subtract your exponents, remember you have to have a common denominator. 1/3 and 1/6, what would common denominator be?
That's 6.
A 6. So I need to turn them both into 6 on bottom. This one already has a 6 on bottom, but the 3, I need to multiply by 2 to get a 6 on bottom. So 2/6 minus 1/6 is 1/6. So this becomes y to the 1/6 power.
Okay. Got it. Okay, now I get it.
And I believe on those problems, the answers are on the back of the review. The version I have, the last 2 people that got a review, I'm sorry, y'all don't have answers on the back, but you can take a picture of somebody else's and I'll post the answers online. But I believe on the back of your review, that's how the answer's written. How could I put this in radical form though? What would this be written as a radical? The 6th root of y? Uh-huh. What else? Number 5, let's do it.
I was thinking the same one.
Ooh, 5's a fun one because it
I was
looks,
like, I already said something.
5 looks like bad, but it's actually really easy. So a to the -2, b to the -5, c to the -11, and it's all raised to the -6 power. So what do I do with the -6 power?
Distributed.
Distribute it into your exponents. So I get a to the -2 times -6 is positive 12. B to the -5 times -6 is positive 30. C to the -11 times -6 is positive 66. Can I put any of those together? Do I have any negative exponents? All done. Kind of fixed itself, actually.
So on one like these, we do not do the switching thing before.
I wouldn't. You can. You would move all this before, and then you distribute the -6, and then you move it all again, and you get back here.
Okay, so it.
Yeah, it kind of depends on the problem. Like, for example, problem number 4 we did right here. Well, you could like have simplified that first before you distribute the -2. And it's not wrong. Sometimes it's faster. For that problem, it is a lot slower to do it. But so for some problems, it is faster. So it just kind of depends on where you're at. Okay, does this review have magical powers that if you do it, all of a sudden you're gonna make 100 on your test?
Yes.
Yeah.
I wish. If I could do it, I would do it. It does not. If you do 28 problems and know how to do 28 problems, can you handle the 14 problems that are on your test?
Yeah.
Probably. You might make mistakes, you might make errors, you might forget something. But in general, when I grade tests and I'm adding 5 points, I'm usually adding the 5 points for the people that did the review to A's and B's and like some high C's. There are very few people that makes 20s and 30s and 40s on the test that did the review and get the 5 bonus points. So there's a correlation there. If you practice, you usually do better on your test. So practice for your test using your review, and I will see you on Wednesday for your test.
Oh, yeah, you're good.
Stop. Stop. Yes.